Right. Good morning to everyone online. Can I just get a thumbs up that everybody can hear me? Okay, thank you. All right, a warm welcome to Turbine Talks. This is part one on end-of-life pathways for wind energy assets. My name is Mafiwa Ramalebana. I'm the Communication and Design Specialist at SAWEA, and I'll be facilitating today's discussion. It's wonderful to have this many people on the line today. I see there's more people joining, and I hope that everybody is excited to hear this forward-thinking conversation that we're going to have today. Thank you for joining. I know we have some SAWEA members on the line as well, partners, stakeholders from across the industry, and just to everybody that's joined us today, including our speakers, you are warmly welcomed. So whether you're a member or not, your participation today is valued and it will help us move this important discussion forward. Thank you. This is a very critical conversation for our industry as South Africa's wind energy continues to grow. We must look forward and ask ourselves questions such as what happens when turbines reach the end of their operational life? How do we recycle responsibly? May I just ask that we mute ourselves on the line? Thank you. Sorry about that. How do we recycle responsibly? How do we repurpose creatively and comply with the evolving regulations to ensure a truly sustainable wind industry? And today's session, as I mentioned, is part one of a two-part series, which will focus on extended producer responsibility and recycling models and repurposing solutions, which will lay a very strong foundation for continued discussion in part two on Thursday. So today we'll be drawing from both local expertise and global lessons that will help shape the pathways that are future fit. But before we begin, I just wanted us to have a few housekeeping notes. Can we just please keep our mics muted during presentations or when we have a speaker on the line? You are also welcome to post your questions and comments in the Q&A section, which is available on the call, and then we will capture those and bring them.
Pardon, Mafiwa, just check you're on mute.
Oh. Okay. Am I audible now?
Yes, please continue.
Apologies. Can someone just let me know where you lost me, Vincent?
It was just after discussing the house rules.
Okay, I'll just start again with the housekeeping notes. Thank you. May I ask that we all keep our mics muted during the presentations and when somebody is on the line. You are welcome to post your questions and comments in the Q&A section. We will capture them and bring them into the Q&A session at the end of both presentations. Both parts, part one today and part two on Thursday, the recordings and the content will be made available to all attendees. The recordings will actually be loaded on SAWEA's YouTube channel and the presentations will be shared via a closeout email. So to begin our session today, we will be having our first speaker, Dr. Mark Williams-Wynn, who prefers to be addressed as Mark. He is the Chief Technology Officer at EWaste Africa. EWaste Africa is a multi-award-winning, legally compliant and environmentally ethical recycler of electronic and lighting waste in South Africa. Mark holds a PhD in chemical engineering and he brings 14 years of experience in the waste industry. He's deeply passionate about implementing sound waste management practices that protect the environment, create jobs, and generate value. Today, he will be unpacking recycling models and the role of extended producer responsibility in the local context. Mark, when you're ready, I'll hand over to you.
Thank you so much, Mafiwa. I'll just try and share my screen quickly. Can you confirm you can see it, Mafiwa?
Yes, I can see your
Okay,
screen.
great. Great. So I am very excited about this, the forward thinkingness of SAWEA in terms of starting to look at, okay, what do we do with the end of life of wind energy generation equipment in South Africa? And I think we are blessed by the fact that maybe we are a bit behind the rest of the world in terms of the rest of the world is already starting to look at some of these ideas. But maybe just to start off, why do we need to even look at this? I just pulled this information in terms of the REAP rounds 1 to 4, the wind capacity. I'm not entirely sure about the amount that each of those wind turbines is producing, but I would estimate that it's probably around 1,000 to 2,000 wind turbines that were installed in REAP rounds 1 to 4. And round 1 to 2 are already around halfway through their 20-year contract lifespan. So you're looking at maybe 600, 700, 800 wind turbines that are going to reach end of life in the next 10 years. And a lot of them are obviously actually all of them are in the western half of the country. And I think internationally, if you look at companies that are already recycling decommissioned wind turbines internationally, I think ENGIE recycled about 90%, 96% of the components from a wind turbine. Ørsted recycled about 98% of the composite material from the wind turbines. So there's a lot of work that's being done internationally in terms of the recycling of the wind turbines. But then you also get situations such as what happened in the USA with Global Fiberglass Solutions, who were promising a solution for the end-of-life management of wind turbine blades. And they were accepting these blades, but they didn't actually have a solution yet. They claimed that they were implementing technologies, but after 7 years, they hadn't recycled a single blade, and these blades were just being stored long-term in 3 sites in Iowa. And so I think it's important to have these conversations to avoid that situation where we've got these end-of-life turbine blades that are supposedly being recycled, but there's no solution in place. And so I think we've got the next 10 years to start getting this right, so that when those blades start to come through, we have the capabilities. So you would have noticed I've focused mostly on the blades, and I'll take you through a bit more of why I'm really focusing on the blades. And I think it's primarily because that is the most difficult to recycle and probably the most hazardous component of the wind turbines because of the glass fibers that are often used in those blades. But maybe just to start off with, and I don't want to focus on this, but just to give an idea of who EWaste Africa is, to show you that we're not just a fly-by-night people such as Global Fiberglass Solutions who are just coming in and saying, no, this is what you should do. So we don't have any processes in place at the moment for the glass fiber blades from wind turbines, but we have been we have been around for 11 years now. And the one thing I did want to focus on is PV. So PV 5 years ago, everyone said, "Oh, it's a future problem. We don't have to worry about it now." And in 2023, we built a small plant just to start testing out how can we recycle these PV modules. And within a few months, it was operating at full capacity. And I think in just this year alone, probably in South Africa, there's probably over 2,000 tons of solar panels that have been recycled. So that's how quickly the market builds up and the demand arises. So I think this is why I'm very happy that this conversation is happening, just from a South African perspective in terms of protecting the environment, making sure that renewable energy stays as green as physically possible. So I think most people on this call would have more idea about the different components of a wind turbine than I do. And so this is what you probably think about when you think about a wind turbine. This is kind of the different components and the different parts of a wind turbine. From a recycler's perspective, this is what we would see. If you start at the bottom, the concrete, usually that's someone else's problem. We don't have to worry about that. The platform, the transformer, there's maybe some oils that need to be dealt with, but other than that, there's copper and there's valuable materials. Your power and internals, that's normally steel, but actually we don't normally even get that. That gets recycled before it gets sent to the e-waste recycler. Obviously the cabling, there's lots of copper, and then in your nacelle there's various different components, but there's a lot of copper, there's rare earth magnets, that sort of thing, and most of those can be recycled. There's some plastics which are irritating, but can be recycled. You've got your oils that need to be dealt with, but those can be recycled quite easily. Then you get your blades. And I figured, seeing as it's a South African webinar, I could use the term AISH, because that's what recyclers would see when they see those blades. Not only because of the materials, but also the sheer immensity and size of them, particularly the newer ones. They are extremely long, and I was actually, it's something that we need to figure out how to manage, because technically, if you look at the requirements of the National Environmental Management Waste Act, you wouldn't even be able to cut those up on site. You would technically need to transport them to a hazardous waste management facility to be able to process them, which means you've got to go through all those processes that had to be followed when bringing the blades to the site. So that's one of the things that we need to look at, and how do we change that? And it's maybe I did actually have a discussion with Michelle, who governor from DFFE, who is presenting on Thursday around that. But I think further to that, there's importance. Well, the first thing is, I read a quote from Dr. Charlotte Stamper from the Circularity Collective, who said that about 85% of a wind turbine is steel. So that's great in many ways, because steel is easily recyclable. So that's a big portion of the wind turbine that can easily be recycled. But the problem is those blades, they might be lightweight, but they are still a lot of volume. And in South Africa, electronic waste is banned from landfill. So even if you was to say, but let's just send them to landfill, it's actually illegal to send them to landfill. So we need to find solutions for them. And I'm hoping that over the course of this webinar and the webinar on Thursday, that we'll come up with good solutions for these blades. And then I think the other important aspect is to consider, what are the battery limits of a wind turbine? I mentioned at the beginning that the concrete platform or plinth is someone else's problem, but I mean, is it, where does the definition of e-waste or electronic equipment start, and where is it just structural material? I think the one test that came to mind is to test and say, well, would the turbine be able to operate according to design without that specific aspect present? And that's maybe one way to test out where do the battery limits of the wind turbine, so that, especially for EPR and extended producer responsibility reporting requirements. But I don't want to go into too much more detail on that. What I want to focus on is, okay, well, what do we do with these wind turbines? So as I mentioned, the landfill of wind turbines is banned in South Africa. So we have to find other solutions, and that's where your recycling comes into play, because, well, by recycling, I'm actually referring to recycling and moving up on the waste hierarchy. I'll show you what is meant by the waste hierarchy in the next slide. But it's finding ways to reuse the materials rather than just dumping them into landfill, where they will sit for indefinitely, because they're not going to break down over a long period of time. But if you look holistically at a wind turbine, and you look at what's called a life cycle analysis of a wind turbine, about 89% of the, okay, we're just focusing on the carbon footprint, not on all the other environmental impacts, but 89% of the carbon footprint of a wind turbine is generated in the manufacturing process. There's a small amount in operations and maintenance and installation, but the vast majority is in the manufacturing process. And so what that means is, if you are taking it and you're just disposing of it, you are essentially wasting all of that manufacturing impact that you've had on the environment. And so it's important to start looking at circular principles to intensify the use of the resources. So rather than just recycling it, are there ways to reuse it, to reuse those materials in different ways? And I think we've got the presentation after mine I'm really looking forward to, because it's looking at those reuse and repurpose applications. And so if you don't look at that, if you just looking at the basic recycling, you're essentially wasting recycling is kind of, you're undoing that manufacturing process, or to use a very non-English word, unmanufacturing the recycling process, and all those inputs in terms of energy usage, chemicals, etc., are wasted because you have to redo it again for another, whatever you would reuse that material for. So the waste hierarchy, it's actually a lot more complex, and there are a lot more levels than this. But I've simplified it in terms of what it could look like for wind turbine blades in South Africa. So obviously, so usually the lowest level of the waste hierarchy is disposal, but because it's banned from landfill in South Africa, the lowest level in South Africa would now be recovery of energy. So that is putting the wind turbine blades into some sort of pyrolysis or process where you can recover oils from the resins, or else using them in co-processing with in cement kilns, etc. But so the whole idea behind this waste hierarchy is the higher up you go, the more preferable it is. And so if you're looking at things, the ideal way to look at using these blades and parts from the wind turbines is reuse, where you are repurposing the blades for other aspects. And I think BladeMade will take us through this a bit more detail later. But essentially, it's looking at things like using those blades for this is what's being done in Europe. Things like bike shelters, bridges, kids' playgrounds, noise dampeners on highways, and kind of protective sidings for highways. And even I saw recently there's a use of these wind turbine blades to stop desertification in China. And I think South Africa is uniquely positioned for this, because sure, these are cool uses of wind turbine blades, but there's limited amounts that you can actually use them. Whereas in South Africa, I mean, we've got a huge crisis in terms of housing for people. It's terrible seeing the number of shacks that are built every day, and there's an opportunity to make use of this material, which is going to have a lengthy time span. And at the end of the day, it's mostly fiberglass, which can quite easily be repaired if there is a crack, in terms of using it for a roofing for a house or something like that. Obviously, it can't be repaired as a wind turbine blade because of the intense forces that it endures when it is on the turbine. But in terms of using it to build houses, to build RDP houses, as a roofing structure, there's almost endless possibility in South Africa. So my question is, why recycle and break down these materials when it has a potential of being a roof over someone's head? And I think one of the arguments against reuse that is you see a lot in the European setting is that the supply is simply going to outstrip the demand. But I would say that in South Africa, we have the demand for use of these components is going to be much higher than is what is seen in Europe. And I don't know if it will really be an issue in South Africa in the foreseeable future. It is of my opinion that this is the route that we should be moving in terms of reuse and repurpose of these blades. But there is also always going to be a need for recycling because there are always going to be components that or parts of it that can't be reused. And just I would like to then, as a chemical engineer, this is what really gets me excited in terms of the different options for recycling. So just at a high level, what are the different options that are available for recycling? There's thermal processing, where you're using temperature to degrade the resins to recover the glass, and also sometimes to recover the resins as a fuel or something like that. So this could be pyrolysis, but it can also just be a furnace that you're using it to generate energy. Then there's other types of thermal processing where you are co-processing the shredded wind turbine blades as a fuel in the production of cement. And the nice thing about this is that the glass actually becomes part of the cement. So there's no waste that's produced from the process. And then the third option is chemical processing. So it's using solvents or acids to dissolve and decompose the resins or the polymers so that they can be recovered, and also the glass fibers can sometimes be recovered. So thermal processing, the first step is you need to shred the blade. So obviously, if you've got a 100-meter long blade, that has to be cut up into pieces, and hopefully that is something that DFFE can guide us on in terms of how can we cut them on site such that they can be transported more easily. And then they have to be cut down to a smaller size before they're shredded, and then move into the pyrolysis unit. So pyrolysis is basically heating of the materials to a high temperature without the presence of oxygen. So if you add oxygen, it burns. But if you don't add oxygen, what happens is your polymers degrade and they form what is called pyrolysis oils. So those can be recovered, and those can be used either to fuel the to actually provide that temperature to do the degradation, or else they can be sold as fuels elsewhere. And so you have the pyrolysis oils come off the top of the process, and off the bottom of the process you get a char, and then sometimes you can recover those glass fibers. Co-processing is very similar, but it just replaces this pyrolysis with the pyrolysis unit with a cement kiln. And you do produce CO2 in that process, and then your cement clinker, which is where the glass fibers are. And interestingly, Wind Europe has promoted this as the best solution for the recycling or the end-of-life management of wind turbine blades, because 100% of the material ends up in the cement, and it's something that, because we are using cement on a large scale and there are a lot of cement kilns across the world, it's something that can be deployed immediately, and you don't need specialized processes. The last process is chemical processing, and in this, the aim of it is to recover or to separate your polymers from your glass fibers. So sometimes the glass fibers can be reused, but other times that they can't, and a lot of it depends on the way that the blades are shredded, and then what the demands are for that glass. So maybe it can't be reused to make new wind turbine blades, but it could be used for other glass fiber products. And so in this dissolution or decomposition reactor, you essentially, there are a number of processes internationally where either you add a solvent which dissolves the polymer, or you add an acid which breaks it down in a different manner. And so then you have to go through a solvent recovery process or some sort of recovery process to recover that polymer and the solvent for reuse at a later point. And then you can also look at drying and size classification of the glass fibers if you're wanting to reuse them in very specific applications. So lastly, just some of the considerations that I have mentioned some of these, but just maybe to reiterate them. The on-site processing in terms of cutting down the wind turbine blades to size. The big challenge with that is obviously with glass fibers. If you're cutting, you are releasing particles which are or could be carcinogenic, and so it has to be carefully monitored and carefully controlled. But from a waste management perspective, it doesn't make sense to have to transport these blades as large 100-meter long abnormal loads when you can cut them into smaller size. So this is something that maybe needs to be considered about changing legislation slightly to enable that. And I think another important aspect, and particularly around EPR requirements, is the clarity on the battery limits. So what is considered e-waste, which are the hazardous components, et cetera, et cetera. But I think there's great advantages with considering the end of life of wind turbines, in that there is great potential for job creation. And then there's also, as I mentioned, the use of the blades for concepts such as RDP housing is immense in South Africa, and I think it's something we need to look at closely to see how can we align with government in terms of providing those roofs and providing materials for production of or building of RDP houses. But I think in conclusion, I'm excited by the fact that we are having these conversations now and not in 10 years' time when the waste is already being generated and we have to figure out what we're going to do with it urgently, so that we can avoid that global fiberglass solutions situation where the solution was promised before it was actually available. And as I've gone through, there are several sustainable options for the end-of-life management of wind turbine blades, and some of the following presentations today and on Thursday will take us through these options. But I think the most important thing is collaboration is key, and it can't be a thing of the recyclers telling you one thing and the developers saying another thing, the regulator saying another thing. We need to work together to make sure that we can implement good processes that enable the protection of the environment and ensure that wind energy remains as green as it is, as green as possible. Thank you very much for your time, and back to the moderator.
Thank you so much, Mark. Sorry, am I audible? Just checking if I'm audible.
Yes, you are. You are.
Okay. Thank you so much, Mark, for your insightful presentation. I think this perspective was really important for us to understand not only the challenges that we're facing in the wind industry, but also the opportunities that are available to build a more sustainable and job-creating industry here in South Africa, particularly. And I don't doubt that anybody on the call did not find this very insightful and exciting and forward-looking. So I want to thank you again for your time and for this presentation. And we look forward to, continuing this conversation further and hearing from our second speaker, who will also build on what you've just started. Thank you, Mark. Thank you. And just to everyone on the call who has joined after we've began, I have inserted the housekeeping rules onto the chat. If you have any general questions that I may have addressed there, you can just check. But we will take note of your questions and comments for Mark, which will be addressed at the end of the second presentation. Thank you. And now we will hear from our second speaker, who I hope I will correctly pronounce his name, Mr. Thijs von Barnau Sythoff, who brings a valuable international perspective on blade repurposing and circular design. Thijs is a project lead at Blade Made. He studied architecture at Delft University of Technology, where his thesis focused on radical circular material use in residential renovations. At Blade Made, he leads projects that transform dismantled wind turbine blades into high-quality products for public spaces, construction, and infrastructure. Through a bold, design-oriented approach, BladeMate demonstrates how waste can be repurposed into innovative, durable solutions. Thijs, when you are ready, the floor is yours.
Yeah, thank you. Thank you very much. Very nice to be here. I'll see if...
Okay.
Yeah,
Let's
that's
just
all
ask
good.
Vincent to...
Yeah, I have
Sure.
to allow... I have to allow screen recording, apparently. Wait just a second.
Okay, not a problem.
Oh. Okay. Okay, I hope it works like this. Yeah. Okay, it should work like this. You should be able to record it now.
Just let us know once you're sharing your screen.
Yeah, I am. I am trying to do that. Oh, okay. Okay. I'm afraid I'll have to rejoin because I have to close the application. I don't know why this is happening, but I have to close the application in order to be able to share my content. That's what it says. I'll just pop right back in.
No problem. May we just ask everyone on the call to just give us 2 minutes to allow Mr. von Barnau Sythoff to rejoin. Thank you so much, and apologies for the inconvenience.
Yeah, there I am again.
Right.
Now should be good. Okay, here we go.
All right.
Apologies for this. I don't really understand why I'm not just toestemming nodig. Yeah, and then I say okay, that's fine.
Thijs, what we can consider as a plan B. If you can email us the PDF, then I can share it on my end and I can fly through the slide deck as well.
Okay, yeah. That should be possible. Well, I think it has to do with the fact that I just now installed Teams app. I normally just join through internet, but that gave its own issues.
Okay, you are welcome to share it with us, and then we will project it for you.
Yeah,
Okay.
that's beautiful. I just have to then also make a PDF because I only had a PowerPoint slide, but we'll get there.
All right.
Maybe in the meantime, I can already say it was really interesting to hear your story, Mark. Mainly because it's the first time that I'm not the only, or we are not the only ones making the point of repurposing and reusing next to recycling. and not only focusing on a technique that at the moment, is just not capable of upcycling with the most value as possible. This is literally the first time that I've joined a conference where there was someone else preaching that knowledge. So that's already very refreshing. So thank you for that. Come on. I'm gonna try something else, because normally I have no issue at all.
Alright.
Just
In the
sharing my screen.
meantime,
Then I
okay.
do that.
All right, not a problem. I
Because
think in the
now,
meantime,
I think now I've joined as well on.
all right.
Yeah.
I think just to allow you to get sorted with the presentation, we already do have 2 comments or questions in the Q&A section from Mark's presentation.
Yeah,
Mark,
please go ahead.
okay. Mark, if you're comfortable to just join us again, and then perhaps we can go through the 2 questions that we have so far.
Yeah, sure, no problem.
Okay.
I can't see the questions myself, so maybe if you can
Yeah.
pass
Yep,
them.
absolutely. Yes. So the first question we have reads, has thermal recycling of wind turbine blades progressed beyond pilot or demonstration phases into commercially viable applications with established industry collaborations?
So it's difficult to say, because there are instances even in South Africa where you have processes that can thermally treat the kind of the plastics and that sort of thing, but at the same time, there's a lot of smoke and mirrors in terms of what is actually available. I mean, that the global fiberglass services is a typical example of this, where they claimed that they were recycling and they were processing the blades, but they actually weren't. So I think there probably are processes, but it is something that I don't know. I don't think EWaste Africa would ever look that direction, because it's not something that we want to do in terms of the lowest level on the waste hierarchy.
Thank you, Mark. Our second question is from Ruben at Anji, and their question is, are there any health impacts or risks associated with fiberglass or any of the materials used on the wind turbines?
Yeah, so fiberglass, I don't think it's as bad as asbestos, but it is still pretty carcinogenic if it is breathed in. So that's particularly if there are broken blades or you're cutting blades, that sort of thing. The fibers can become airborne quite easily and can be breathed in. And once they enter your lungs, they can cause damage, which could lead to cancer. So it's something that should be avoided, and it can be avoided through special processes, but also just making sure that you're wearing the required PPE when handling particularly broken or damaged blades, or if you are cutting blades, so that you're not breathing in the dust. I mean, it'd be similar to if you go to a boat building facility where they're building boats out of fiberglass. You want to make sure that you're wearing a dust mask so that you're not breathing in those dust fibers.
Thank you so much, Mark. I will let you know as well at the end of today's session if we have any further questions related to your presentation. Really appreciate your time answering them at this moment. I see that Thijs' presentation is also ready and projected. Thijs, when you're ready, I'll hand over to you. Sorry, you're on mute.
Yeah,
Okay.
I am unmuted now. Okay. Well, after a few hiccups, well, thanks very much for being here. I'm gonna give a little presentation, of course, on BladeMate, on our company, what we do, but also on the problem at hand, which is first place. And I've titled this presentation Sustainable Continuity. And if we go to the next slide, please, then this seems like a very obvious statement that wind energy is sustainable energy. But it's and it should be. Wind energy should be very sustainable energy because, again, next slide, please. You know, why are we doing wind energy in the first place? Why are we going through, having to deal with very ambiguous cash flows where our fossil fuels have very predictable revenues? Next slide, please. And where wind energy is very complex in planning and permitting and integration, where fossil fuels are, you know, just business as usual. Well, it's because that was the whole reason that we started with wind energy, is because we need a sustainable way to power our future. But next slide, please. At some point, we've overlooked a few things. And what we've overlooked is the material intensity. That was really nice, what Mark also illustrated, is this 87% of the CO2 comes from the manufacturing of the turbine. Because once it's there, it's very sustainable, but it's very high in material intensity. And we've never really thought about what to do with the turbines once they have to be decommissioned. Please, next slide. So what are the metrics on this blade waste? So Mark already explained a lot very nicely, the difference between the different components. So I'll just leave that be. So you now know that indeed blades are that's a pain point. I've been presenting this slide for a while, and there's a few things interesting. One is that 600 tons in 2050. I must say that a lot of this is from a European perspective. We're a Dutch company. I'll come to that in a second. And so a lot of it is on a European perspective, but I think it's really nice for you also from this South African perspective, where I believe, if I have the metrics right, most of your parks are now on half-life. So you actually have the time to avoid some issues that we in Europe have now. So 600 tons of blade waste in 2025. Well, it is 2025, so this is a current issue. This is not a future outlook anymore. 400,000 tons of blade waste in 2040 and 43 million tons since 2050. These are some metrics that I've presented so far, and not very long ago. I think it was a week ago, with another somebody told me, said 530 million tons in 2030 for Europe. Well, that was from a publication. I'm not sure if that's correct, but we can conclude that it's still, we're not sure what the real numbers are, but the numbers presented here are probably on the lower end of the truth. And what do we do with it? Well, again, Mark explained it very nicely, so I'm not going to spend a lot of time on it. But in Europe, it's the same as in South Africa. Landfill is forbidden. So it's just simply not an option. Then incineration, mechanical recycling, pyrolysis, and solvolysis, they all have a very moderate or low CO2 reduction in comparison to incineration. And well, there's a lot of issues with recycling at the moment because it's just not on a level yet where we can really make high quality products out of these blades. Next slide, please. Then another thing that I'd like to talk about is circularity. So I've visited a lot of in the wind industry. There's a lot of fairs, like the Big Wind Europe fair for us. And also here in the Netherlands, there's a lot of events, and we talk about sustainability in the sector. And then I get a lot the text, yes, circularity, but we're also already working on circularity. We're working on, for example, recyclable blades. And that is a very good and very important development, but that's only preventing the problem in the future. And we have a current problem that comes from blades that have been produced in a way that are not recyclable. Also, recyclable blades at the moment are only 27% recyclable. That's also a good footnote. So just saying yes, but we're already investing in circularity in our new products does not mean that the existing issue will just sort of magically solve itself. It's not going to magically solve this 400,000 ton and 43 million tons that is projected at the moment. That is still coming. Next slide, please. So we need good end-of-life strategies for this. And if I talk about end-of-life strategies, I talk about reuse, repurpose, and recycle. And yes, in that specific order. Why in that specific order? Next slide, please. It's in Dutch, but the most important words are in English. The R letter of circularity. It goes all the way from refuse to recover, and the higher you are in this hierarchy, the more circular and the better it is for the environment, and the more quality you have in reusing your materials. So next slide, please. So reuse, that's the first. Repurpose, that's really high. Reuse is the first, or it's R3, and it's in the extending the service life of products and components. Repurpose is quite below that, also as R7, but it's still in the category of extending service life and products and components. And then next slide, recycling, although that it's only one beneath repurposing, it's a completely different category, and it's just effective use of materials. Next slide, please. So again, reuse, repurpose, recycle. Reuse is the best, but it just happens not as much because reusing a wind turbine blade literally just means it comes down from the turbine and you decide this is still good to go, and you sell it to another wind park owner, and it will just have another 10 or 15 years being itself. It happens, it is the best option, but it's definitely not a solution for all our material right now, because a lot of the blades are just not capable of safely and also of safely having this second life. Then comes repurpose, that's what we do, and then recycle, of which Mark has told you a lot about. So now let me introduce you to BladeMate. Next slide, please. We're a company in the Netherlands, and we believe in this repurposing strategy before recycling. So, well, this is what we do. Our mission is impact, and we give this ever-growing material stream of wind turbine blades a second life as building material with an internationally scalable, immediately applicable, and sustainable solution. Next slide, please. So again, this metric, but now, so we're on both ends. So we are all the way at the top, because if you use a wind turbine blade for something you would normally use steel or concrete or, well, any other material that you use virgin resources, then you don't have to use these virgin materials. So you actually refuse to use those materials. And then, of course, from the wind energy perspective, or the wind sector perspective, the repurposing of the wind blade material is, well, repurposing. Makes sense. Next slide, please. So what do we then do with it? Well, again, as said, we use it for urban furniture. We use it for playground equipment. We do custom designs and artworks. And we're recently moving into infrastructure with noise barriers, bridges, and also facade panels that I'll talk about. And that is our part of scaling up. Please, next slide. So where do we come from? This is the Wikado playground here in Rotterdam. Rotterdam is the second largest city here in the Netherlands. It's still there. It's quite old already, 2008. So this was long before the discussion on end of life issues for wind parks was really the case. And this started off with completely different perspective. It was the design idea and trying to minimize virgin materials for anything that we build. And we found blades in the backyard of a farmer, and we said, hey, can we use those? And saw them up and make a nice playground out of it. And it was only later when noticed that it was a real issue that we shifted. Next slide, please. That is going to show you another instance of a nice playground. Nice. Next slide. Then we moved into urban furniture. We experimented a lot with making benches and urban configurations. The one on the left, our boulder blade, is something that still catches a lot of attention. It does a sort of roadshow through the Netherlands, and a lot of institutions are very willing to have it in front of their museum, for example, for a couple of weeks. But as said, our mission is impact, and these 43 million tons of blade waste, you're gonna have to make a lot of playgrounds and a lot of benches if you want to repurpose that with these strategies. So we're moving towards scalability. Please, next slide. Oh, another instance of a nice bench. Scalability. We're at the moment on the verge of 3 projects, of 2 of which I can tell you something. This is our pilot for a noise barrier along the highway of the A58 in the Netherlands. And this exact picture I've already also saw on Mark's slides. But on the 2nd of July, we actually opened a physical test barrier. So next slide, please. And then the picture will change. Next slide. Yeah, there it is. So we've built 60 meters and we're testing it now on, already have tested it on sound quality. So the soundproofing, the actual quality of the soundproofing, because it's very nice that it's sustainable and it looks cool, but it also has to do its job, of course. The full life cycle analysis, the financial, the financial picture of it. And this December, we'll have this, ready to market. And then we'll start implementing it at first in the Netherlands and hopefully quickly also in Europe. But it looks very promising. It's one of our cooler projects, if I must say so. Can say so. Also because talking about scalability and impact. Please, next slide. By doing this, we actually repurpose 270 tons of blade material for every kilometer that you build with this sound barrier. So that's actually starting to get effective. We're also in the process of building this beautiful building here. In here, we'll repurpose 160 25-meter blades that will come down from a park here in the Netherlands for the first really large-scale onshore park that will come down here in the Netherlands. And well, I think it's no, I don't have it ready, the right metric, so then I'll just rather not say, but at least it's 160 blades, and that will then result, next slide please, in 320 tons of blade material. And as said, right now in Europe, we have 600 tons in the year 2025. So when this project and the other project are finished, then realized, then we have actually already solved almost all of the blade waste for this year in Europe. Yeah, also proving that with some yeah, smart design thinking, you could actually make a lot of more impact than you'd think at first. Next slide, please. Then this is also nice. I think I have to speed up a little. This is a tiny house that we built with Vattenfall. Yeah, I think it speaks for itself. It's yeah, it just looks really cool, and it's a cool idea. And we're looking to scale this up. This is quite a luxurious example, but we can really see also aligning with what Mark said, to use these as shelters and really low cost, affordable housing, rather than this is like a very luxury tiny house apartment. But that is also what Vattenfall at the moment wanted as a result. Yeah, really interesting pilot, and we now have an outstanding orders to build 10 more. So that's yeah, that could be a great start of also making this a scalable solution. Next slide, please. Then how do we work? So we work with a circular chain, and our idea is, and this is a nice moment to clarify this for you. Repurposing is not the end strategy, because our material also needs to be, well, has an end of life. A sound barrier also reaches an end of life phase, and then you still have this same glass fiber reinforced polymer, very hard to recycle stuff. But once we've placed it with high value in the public space, so it's not waste that only costs a lot of money, but it actually has value and economic value, but also functional value in the public space, then we can give the recycling industry time to develop. And after 30 years, you betcha, with all the money going that way, that they have proper techniques to actually recycle properly with high quality of end material. So we take the blades, it goes to our storage and transformation facility. Then we actually place this material in the public space. So you could say it's sort of a, yeah, functional landfill almost. And when it then has reached, we'll see, well, maybe it can reloop again from a sound barrier. It can become something smaller, up to the point where the material is really actually at its end of life. And then it can go to a recycling facility, and maybe by then it's even possible to repurpose the material for new blades, because that's also, of course, a large issue. Next slide, please. But what is happening at the moment? I would have imagined that these things that we built with it, that would be where people would have their doubts. Like, okay, a sound barrier made of blades. I don't know. It looks weird. It's very different. It's building with waste. How do we go about it? Same goes for the architectural projects. But actually, very, very positive. People are welcoming our designs with open arms. Where do we have the struggle? From the wind energy sector. And that is where we are actually solving an issue. So next slide, please. The wind energy sector is very happy to supply us with material. They even say, oh, I can contribute to this project by giving you my blades for free. But we all know, your blades are free. It costs you money. So if you give then you actually don't pay for something that you would pay for normally. But yes, we like the blades, but we also really need transparency, collaboration, and we need investments. So next slide, please. Why would you invest in end-of-life strategies? Well, I can understand very good why not in the first instance. What's the issue? I mean, at first, when the first parks were built, No one took into account financial budgets for sustainable decommissioning of these parks. So it has to be paid for now. And so the wind park owners, they have a huge bill on their table to, well, to sanitize their parks. And usually, especially in the Netherlands, this sanitation is also mandatory. It needs to go, and you now need to pay. So then it's not that strange that for wind park owners, they say, okay, it just needs to go as quickly and as cheaply as possible. Please, next slide. And well, it's not only from a whole turbine, it's not only that it's well recyclable, but that also means that it has value because it is a resource. The blades and the nacelles, all the glass fiber, as the way it works now, it has a negative value. I mean, for us as well, we get paid to get the material. There's a gate fee. That's the market, because it is waste. But why is it waste? Because we don't see it as waste. Next slide, please. From a blade mate perspective, it's not waste. It's a resource, and a resource logically has value. We don't see this as a very hard to recycle, immovable object. What was the word? Ew, or something like this. We say, wow, I see, I don't know, a 1/15th part of a sound barrier. Same goes for the nacelle. I see affordable housing. I see the chance to solve housing issues. So that automatically gives this material value. At least, again, please. Next slide. Would that mean that we've now got the problem solved? Next slide. Well, at the moment, we need this gate fee. We need this gate fee at the beginning of our process, because otherwise we cannot make a product out of it that then on the other market is sellable at a reasonable price. That because we have very high production costs, because everything is very experimental, one-off. In other words, we're not at a scale yet where we can make the production affordable or more affordable. And that is because, well, there's a lack of also collaboration and investment from the wind energy side. If we would make huge collaborations where we can go from project to project to actually planned treatment of this material. And then I don't only mean us as Bleakmate, I mean the repurposing strategy, and any company that does something with repurposing strategy. It's about investing in that broader vision. Because if you flip that reasoning around, if there is money, then we can scale up, and then we can actually make the production a lot cheaper. And that means that we could then, in the end, actually maybe even pay for the material. And then that way, wind park owners and the whole sector can actually profit from their blade materials and nacelles, because it's no longer a very expensive to get rid of waste, but it's a resource. Next, please. So the repurposing end-of-life strategy, it is the highest achievable air value after final dismantling. It is also directly applicable. It is scalable, and it gives recycling a time to develop, and it can retroactively assign value to things that we now count for as waste. And this would, in the future, offer opportunities to further reduce dismantling costs. Next slide. So we need each other, acknowledge the problem, be transparent, work together, invest, and then you can reap the benefits. And I'd like to finish with the fact that you're already doing this seminar, this webinar, that you're well on your way. And well, it would be beautiful if you guys are capable of avoiding the issues we have now in Europe because you're earlier thinking about the right solutions and preparing the right strategies. That was it. Thank you very much.
Thank you so much, Thijs, for this very fascinating presentation. It was very interesting to see the different ways in which the blades are being repurposed. And I hope that everybody on the call also found it interesting and equally as fascinating as I personally did. So we will now be moving over to our Q&A session. Noting that we have already taken 2 questions earlier with Mark, I will hand over to my colleague Vincent just to help us facilitate the Q&A session. Thank you.
Thank you, Mafiwa, and also thank you to the presenters. Before I go to the Q&A section, maybe just the first one for Mark. What would be your recommended approach for an aging plant or IPP when they are starting to consider end-of-life strategies, i.e. the feasibility studies and the optionalities between repurposing, repowering, or extension?
I mean, that's a whole different aspect, and that I suppose is very dependent on the economics of, in terms of extension, what is the not quality, but what is the how are the blades looking? Can they last longer? Are they starting to show signs of wear? I mean, in terms of repowering, I think that also comes down to an economic aspect, but maybe that question in terms of what was asked of me was more in terms of, well, I think the key thing is at the end of the day, the IPP, the person who's running that plant is responsible to make sure that that waste is properly managed. So they need to speak to a licensed recycler to start to put together a plan of, okay, well, what are we going to do with these blades? How are we going to manage them? I mean, it comes down to the preference of the plant operator in terms of, well, do they want to look more at reuse of the blades in applications such as building houses, etc., or are they happy with other processes, recycling, whether it be thermal, chemical. So I think these are the conversations that we definitely are open to start having, to start exploring, to almost start looking at test or pilot processes, or what's the best option for this specific blade, the specific operator, etc. And I think that there's a number of different recyclers out there. So just to try and be a little impartial, there are a number of recyclers out there, and it'd be good for the operators to speak to them and to see which is their preference in terms of recycler and what is the preferred route of using these or end-of-life management of these blades.
Thank you, Mark. Next question for Thijs. Thijs, the advocacy efforts through the municipalities or owners of parks and councils, how does BladeMate create that demand for the usage of urban furniture, as well as what you mentioned now with the sound barriers?
How do we create the demand? Well, the demand luckily does not have to be created. So, for example, for sound barriers, at least here in the Netherlands, there is like a national plan where there is a need for a lot of sound barriers because we've been making a lot of highways broader, but we did not take into account the effect on nearby villages in terms of noise pollution through the years. So there's this large plan to actually build a lot of sound barriers. And in the meantime, there is a national plan where all infrastructural works need to be circular, sustainable. We have a net zero 2050 target as being the Netherlands. So our government is actually struggling with this sort of, and we need to build a lot of stuff, and it needs to be sustainable in that sense. So our product actually fits both these needs. Again, it's mainly how do we organize the dismantling of a park, transport, getting it. It's connecting the flows of material with the needs as efficiently as possible is a higher challenge, or is a bigger challenge than finding places or finding needs, because the need is actually there.
Thank you, Thijs. Then a question to Mark. OEMs have differing compositions of blades, the type of polymers or reinforcement. Have you approached the main operational OEMs in SA to potentially partner on investigating blade construction, hence to identify methods for recycling? And could South Africa partner with international research on recycling agencies for blade recycling?
Yeah, so I do recognize that there are a number of different compositions of the blade material. I mean, some blades still contain wooden insert inside. Others are more hollow inside, and then even the resins, different polymers, different resins. And so I think in some ways that's why the reuse and repurposing the blades is easier, because you don't then have to worry about, oh, but this blade is this resin and this blade is this polymer material. They all can do the same thing in a reuse environment. So as EWaste Africa, we haven't done any sort of we haven't spoken to any operators at the moment. We're open to have those conversations. And I think, I mean, it would be great to pull in expertise from overseas, because, I mean, they have so much more experience. And I think, I mean, the starting point has been having Thijs present, because they've got their first one, he said, in 2008. So that's 17 years of, was that 2008, Thijs? 17 years of experience in this, in looking at reuse of the blades. So that's a big jump on what we can, and we can use that experience, whether it be recycling, whether it be reuse, to get ourselves there immediately, rather than trying to do all the work again.
Thank you, Mark. Thijs, a question back to you. As you've seen as we've seen now with the urban furniture as well as the sound barriers, of course, there's a good turnout of employment opportunities emanating from that. Is it specific skills, or is it your generic contractors that also help assemble and construct the wind parks that can also be reused or repurposed for assisting with the construction of some of these facilities?
Yeah. Well, so we've worked with, let's say, general partners, but we've worked with the same partners for a while, and we do notice that once it's not someone's first blade project, that helps a lot. Especially people who are in, let's say, the decommissioning industry. They just have some basic knowledge of the material, and if you ask someone to make a sole cut in such a way, if someone is not completely surprised by what they find once you saw open a blade, that really helps. I would say it's not necessarily super specific skills like that you need to go. I don't know. You don't have to be a composite expert to build our projects, but having general knowledge and experience with working with composite material definitely helps.
Thank you. Then I see there's a question for SAWEA. So from a circular economy and sustainable energy transition perspective, the key driver for adoption of circularity will be fundamental development of policy and regulatory changes. One of the key principles is designing out waste and circulating products and materials at their highest value. How is industry or SAWEA influencing and driving circular economy principles in South Africa? Okay, then please share links and policy and regulation, if any, at the value chain participants must adhere to. Just to maybe come in there from a South African or SAWEA perspective, would be that we are well aware of the EPR regulations, and in part 2, Michelle Govender our chief directorate from the DFFE would be uncovering a lot of that, what the responsibilities are, the regulations in its newest promulgated form, and what end users, i.e. developers, IPPs, as well as OEMs, need to commit to. Thijs, is there something you would like to add from an European perspective from the directives that you use as a guidelines in respect of circularity?
That was a long question. Could you maybe rephrase it just that I'm sure that I understand it correctly?
Maybe just European policies guiding
Yes.
circularity.
Yeah, okay. I think in Europe, at the moment, there's a lot of local laws. That's not just true for the Netherlands, but like local initiatives that do ensure a certain level of circularity. However, on a European level, I think it's somewhat lacking, and that's what we're struggling with as well. So just to give you a simple example, European Union decides, okay, we ban landfill since the 1st of January 2025. Because it's funny, I heard you say, Mark, it's not that in Europe blades are not considered actual e-waste. So that it's different regulatory, but they did decide, okay, specifically these glass fiber reinforced polymers, you can't do landfill anymore. Now that did give a little boost on recycling and repurposing and this whole, okay, so now we have an actual issue that we can't hide underground. But then it stops there, right? So then it's back to the market for, okay, now you guys just fight it out amongst yourselves. Whereas if there would be more regulations on a European level, then it's also much easier to solve the issue on a more international scale, because now all these waste regulations and how to deal with something and what does stuff cost and is something prohibited or not, that still differs also within the European Union. So, I mean, yeah, long story short, I think there's still a long way to go, and it would definitely help.
Thank you, Thijs. Mark, question to you. What technology could be used to minimize CO2 emissions in a pyrolysis plant?
So your pyrolysis plant actually wouldn't be producing CO2 emissions. So pyrolysis is essentially you are combusting without oxygen. So it rather is decomposing the components into smaller chain hydrocarbons, and so there's very little there's very little emissions in general, or gaseous emissions from a pyrolysis plant. I think the main emissions would be if you are using a fuel to heat the actual or provide the energy for heat. In that case, obviously you're burning, so you're using oxygen to burn the fuel. And for that, I mean, you'd have to start looking at ways of carbon capture, that sort of thing, which that's another whole level in terms of, I mean, that's what Eskom is having to look at, and that's what's kind of being driven around the world in terms of fossil fuel energy generation. How do we minimize the CO2 emissions? But I think the pyrolysis, there's no CO2 emissions. Your co-processing with cement, there are CO2 emissions, but there's CO2 emissions from the cement kilns regardless, because you essentially are replacing your fossil fuel energy sources with the resin material if you are co-processing. And so you essentially have very similar CO2 emissions from cement. And I think that's why cement is probably one of the highest CO2 emission generators worldwide, just because it's how the cement is actually made.
Thank you, Mark. Then just another question, Thijs. How are the European governments encouraging or incentivizing the reuse, repurposing or recycling of blades instead of shipping overseas for disposals?
I'm not sure if they are at the moment, is the fair question, is the fair answer. So I don't think we actually ship it overseas, but don't pin me down on that because that's maybe where the question comes from. But no, that's one of the things it really comes from initiative like us from the market side that tries to convince the other side of the market to do things in a way, whereas regulations could help us a lot, but at the moment, there's not necessarily, it's not necessarily in place. Basically, shipping waste across borders is always tricky. So I think that sort of keeps it a bit between between your borders. But I would say that there's a lot to do in terms of regulations. But it's also not my area of expertise, so please don't take my word for it.
Okay, thank you, Thijs. No problem. Drawing that back to the South African example, how can we, so now we discussed the European regulations, and Mark, how could we set up that from a South African perspective and help drive industrialization and also small, medium, micro enterprises in respect of job creation for end-of-life value chains?
I assume it's referring to the idea of setting up blade end-of-life management. And so I think one of the key things is looking at things like those micro homes, those furniture parks, that sort of thing. There's definitely scope in there for SMMEs to be involved in actually. I think the question is, how do they get material, and what is that custody of the waste from the operators to the SMEs, so they can be using it in their processes to make furniture or to make modular houses or whatever they might be doing. So I think it's something, and that's something maybe that can be driven through producer responsibility organizations in terms of the EPR regulation, to support the SMEs and enable them to get to a point where they are able to offer the service in a way that's, I mean, the last thing you want is for these blades to be sent to someone for reuse, but they're actually just cutting it and throwing half of it into landfill and operating under unsafe conditions, cutting them without proper PPE, that sort of thing. Mm-hmm. So I think there's a lot of things that need to be considered, and so I think training and education is critical in that, and ensuring that there is a proper custody of waste, and that the final users are aware of what the hazards are with the fiberglass material, etc.
Thank you for that. Anything to add or to that, Thijs? All good?
Yeah, no, what I can now and circularity later, and also the difference, making a difference between, for example, recycling and repurposing and reuse. So, for example, I know that there are, if you look at building law here in the Netherlands, and I think that's goes for a lot of European countries, in new buildings, we actually have a certain level of secondary material that needs to be used in this building. So that it already says it needs to be secondary. So you need to reuse something old rather than make it so that it can be reused easily in the future. Because these, and that goes the same with dismantling, for example. Right now, you could say in a tender, okay, we want a certain percentage to be, to not be destroyed. But if that just means, if you can solve that by just simply throwing it into the incineration because you make the argument that you make energy out of it, then by law, you're doing great stuff. But we all understand that you're just burning it. And there's and it's specifics like these that are not in place yet. And if you make that more clear and you specify the differences between recycling, reusing, repurposing, and also for if you decide, okay, I want to repurpose material, that also means that from the markets where you want to use the material, there needs to be room for that. So you need to check whether now it is actually easy or very hard to build with waste in South Africa, for your example, because it could be that there's actually regulations in place that say, oh no, that block that. One of the things, for example, that's always in the way if you want to work with secondary material is, what's that? Well, who pays if it goes wrong? If I sell you panels from reused wind turbine blades and one of them, or it cracks and it gets leakage, for example, I can promise you that Vestas will not pay for that because it was once their blade, right? So it gets really, it sometimes gets really tricky. So it's not only focused on, if you believe in reuse and repurpose, then look further than your own sector and also look at, okay, if we want to reuse and repurpose, in which sectors do we want to reuse and repurpose, and are regulations in place, or are they free or open to actually do what we want to do with it? Because that can also bite you in the behind if you're not well prepared.
Thank you for the answers. I'm going then to hand over back to the program director, Mafiwa. Appreciation to the audience also for the insights shared, as well as the presenters.
Absolutely. Thank you so much, Vincent. Thank you again to both our speakers, Dr. Mark Williams-Wynn and Mr. Thijs von Barnau Sythoff, for the valuable perspectives that we received today on recycling and repurposing. I also just want to highlight the unique value of today's session, having the privilege to hear from international experts giving us a global perspective on recycling and repurposing, and showing us what is possible, what's been done elsewhere, and how bold and innovative these approaches can shape circular solutions. So in part 2, on Thursday, we will be building on today's foundation with insights from regulators, closure experts, and engineers, providing a broader view from of a local readiness and policy frameworks. And we do look forward to seeing you in that session on Thursday. On behalf of the South African Wind Energy Association, we would just want to thank everybody for participating and engaging today. Please be on the lookout for the recordings and the resources from the session and Thursday's session as well. And just a reminder to everybody online, if you registered for today's session, you are automatically registered for part 2. So you can simply just join the call on Thursday once again. Thank you so much for your time today. We wish you a productive day ahead, and we look forward to seeing all of you on Thursday. Thank you, everyone. Thank you, Mark. Thank you, Thijs.